Good evening, sir. This is Harsh Malani of Karunya University CST department. This is my data structure ninth program. In this program, I am going to tell you about the binary tree search. Now, I'll be starting my program by using a structure function, which is nothing but structure t node. Okay, then I'll initialize something that is int data, and t node first pointer of one child, t node pointer of our child. Now, for operator, then I'll be using pointer root equal to null. In that means in the root which is there in the tree is null. Then I'll again initialize void insert tree in int v, void insert t node pointer ptr, t node pointer temp, bool search int n in t node pointer ptr, void insert preview. Now I'll start the inner code, inner trees of it. So t node temp t pointer temp equal to new t node, temp of pointer array data equal to v, temp array data first child is equals to null, temp array r child equal to null. If root equal to null, root equal to temp, else insert root temp. This program is all about, like, first we have to, in a search, if there is a variable, if it says that we have to insert this element. So after inserting this element, an element, then we have to check whether it is greater or it is lesser. If it is lesser, it goes to the left hand side of the row, and if it is right hand side, if it is bigger than the number initially, it goes to the right hand side. Now I'll be using a void insert t node pointer ptr, if it pointer array data less than ptr pointer data, if ptr pointer data first child equal to null, ptr pointer array first child is equals to temp, else insert ptr pointer data first child temp. Else, else we'll be using if and else statement again. If ptr of r is r child equal to null, r is nothing but right hand side and l is nothing but left hand side. ptr pointer array r child equal to temp. Else insert ptr child r equal to r child temp, void preorder. The first one which I explained you recently was insertion. Okay, now I'll be explaining you about pre-order. Order, if ptr is equals to null, it will return the value. If cout ptr pointer array data and some initial value. Pre-order ptr child left child. Pre-order ptr pointer array. This ptr, if the number, if the array is empty, it will return the value. If it is not, if the array is not empty, then it will give like pre-order. If it is less, it will go to the left hand side. It will go to the right hand side. Now void in order. Now I'll tell you about the in order function, in order function. If ptr is equals to none, return. Else in order ptr pointer array first left child, cout ptr array date in something, some value. In order ptr pointer array r child. This is nothing but if ptr is null, in order, then it will go to the left hand side, or else it will go to the right hand side. Now post order. If ptr is equals to null, return. Else post order ptr pointer array for left child, post order ptr pointer array right child, ptr data. Now, for example, in a post order means, like, first it will initialize, first it will give the value, then it will be showing the point. Now when we are searching, if we want to search the element in an array in binary tree, we give this comments as we pass like this. If an else statement will be using an if and else statement. If ptr is equals to null, return the value. else if n is equals to ptr point array data return 1, else if n less than ptr pointer array search n comma ptr comma left child else. Now here it will check if now for example, if the number you have given is less than the number which you have initialized which you want to search, then if it is less than, it will show you the left hand side left child. If it is higher, it will show you the right hand side. Now I'll write the uh, int method, int statement. Then in int will be int main. I'll initialize the b, c, h and s. Now I'll be using for loop. In this for loop, we have to first initialize I is equal to like I is equal to 1. Like will be telling that I is equal to 1. It is not lesser than 1. And then this is for defining a function which is like I greater than 0. Whenever you are checking the value, if it is less than 0, it will go out. If not, it will go in. If it should be always greater than 0. And then I increment out. Now I'll give you three in this initialize three options, four options. First one is insert, second one is print pre-order, third one is print in order, fourth one is print, fifth one is search. Then see in search switch case. Now in switch cases, I'll be using this one. Out enter the value to be entered. V insert tree. It will insert the value in the tree. Break. Then case two will be post order. Post order pre-order route. Case 3 will be in order. Case 4 will be post order. Fifth case will be the entire element which is to be searched. And then in this we'll be using if and else statement. If the element is in present, then it will show C out. If enter is not present, it will break the value. And then case 6 default return 0 break default. In case 6 it will show invalid input. Now I'll show you the output for this program. Right now, first let me tell, choose first option. Insert, let's say the value to be inserted is 23, 24, 20, 24, 25. Okay. I'll be invalid input. Now I'll show you the second one. In the second one, it will show 23 input. Okay. Then I'll put 3. In third, 23 has entered. Then I'll show you fourth option. 23 is again entered in post order. Now I'll show you the fifth option, search. Now let's check if if we want to search an element 23. Now I'll see. Here it will be showing that the element is present in the tree. I gave you three inputs so that I wanted to show you that in a binary search directly you can't assign three values. It goes step by step. First we have to initialize one element, then the second one, then the third one. This is all about binary search tree. Thank you very much for watching my video.